Forget the iceberg. The true anomaly of the Titanic is not found at the bottom of the Atlantic. It is found in the brutal, mathematically impossible physics of its creation in 1909. We are told that an unmechanized workforce, armed with nothing but hand tools, primitive steam winches, and animal fat, somehow forged, transported, and perfectly assembled 46,000 tons. The mainstream historical record demands that we accept a logistical miracle. But at the Titan Metrics Audit Desk, we do not evaluate romantic folklore. We audit structural physics. Let us open the ledger.
46,000 tons of structural steel do not magically materialize in Belfast. Before a single rivet can be driven, we must audit the raw material supply chain. To smelt 46,000 tons of marine-grade steel in the early 20th century, you require an astronomical volume of raw resources. Based on the thermodynamic efficiency of 1909 blast furnaces, forging this mass requires approximately 100,000 tons of raw iron ore and over 50,000 tons of metallurgical coal. That is 150,000 tons of raw deadweight that must be extracted from the earth, loaded, and transported to the foundries. Let us apply the wagon equation. A standard heavy-duty freight wagon of the era, pulled by a team of draft horses, had a maximum safe payload of 3 tons. To move 150,000 tons of raw ore and coal from the mines to the railheads requires 50,000 individual wagon trips. Even if we grant the existence of local steam rail networks, the logistical transfer of this mass from trains to cargo ships creates a fatal maritime bottleneck. The port of Belfast was a busy, congested commercial hub. To import 150,000 tons of raw materials specifically for one hull, on top of the existing daily commercial traffic, would require a continuous, unbroken armada of heavily loaded transport ships docking, unloading, and departing 24 hours a day. The regional transport infrastructure of 1909 should have been entirely paralyzed, just feeding the blast furnaces. Yet the official narrative treats the arrival of this impossible mountain of steel as a seamless, routine operation.
Once the steel arrives, you cannot just lay down some wood and start hammering. You require an infrastructure matrix capable of managing impossible deadweight. To build the Titanic and her sister ship, the Olympic, the Harland and Wolff shipyard had to construct a specialized scaffold over the slipways. They built the Arrol Gantry. Mainstream historians point to the Arrol Gantry as the ultimate proof of early 20th century capability. We point to it as the ultimate circular paradox. The Arrol Gantry was a colossal, heavy industrial steel web. It stood 220 feet high. It weighed over 6,000 tons. Let us audit the kinetic logic of its construction. To build a megastructure, you need heavy cranes, but the Arrol Gantry was the crane. How do you hoist, align, and perfectly secure 6,000 tons of structural steel 200 feet into the freezing air before your heavy lifting equipment is actually built? You cannot pull multi-ton steel girders into perfect vertical plumb using hemp ropes and steam winches on the ground. The wind shear alone off the Irish Sea would turn a 2-ton steel beam into a lethal swinging pendulum. The official ledger glosses over the catastrophic danger of this assembly, treating the erection of a 6,000-ton steel matrix in a wind tunnel as a routine Tuesday. It is a logistical phantom, a monumental structure built to justify the existence of another monumental structure. But the gantry is only the frame. Let us audit the skin.
To understand the true corporate deception,
we must move to the microscopic level. The Titanic was a jigsaw puzzle of 2,000 massive steel plates, some measuring 30 feet long and weighing up to 3 tons each. To hold this megalithic puzzle together, the shipyard relied on a single piece of technology, the rivet. 3 million of them. Mainstream historians proudly point out that the Arrol Gantry was equipped with hydraulic riveting machines. We acknowledge the physics of hydraulics, but the gantry cranes could only reach the straight, flat sections of the hull. The complex, curved geometry of the bow and the stern, hundreds of thousands of the most critical structural rivets, had to be driven entirely by hand. Here, we expose the convergence of a physiological deficit and a documented metallurgical fraud. To save time and corporate capital, the Harland and Wolff ledger reveals they did not use premium steel rivets for the curved sections. They sourced substandard best wrought iron rivets. Wrought iron contains slag, a glass-like impurity. To create a watertight seal, this iron rivet must be heated in a portable furnace to roughly 1,500 degrees Fahrenheit. It glows blindingly white. 2 men, standing on precarious wooden scaffolding suspended 80 feet in the air, must violently strike the glowing end of the rivet with heavy iron sledgehammers. They have only seconds. Let us calculate the caloric deficit of the human engine. Violently swinging a heavy iron sledgehammer into solid steel against the clock in freezing temperatures requires an immense, sustained metabolic output. A biological unit performing this level of continuous, extreme kinetic earth-moving expends roughly 5,000 to 6,000 calories per day. In 1909, the diet of an Irish shipyard laborer consisted of bread, tea, and cheap cuts of meat, yielding a maximum of 2,500 calories a day. The mathematics of biology are absolute. You cannot output 6,000 calories of kinetic energy on a 2,000-calorie fuel source. Within weeks, the biological engines deplete their muscle glycogen. Fatigue leads to a drop in striking force, and this is where biology kills the metallurgy. If an exhausted worker strikes the rivet too slowly, the freezing winds of the Belfast winter cool the substandard wrought iron before it is fully deformed. The internal slag matrix crystallizes improperly. It becomes incredibly brittle. It behaves like glass. When the Titanic grazed the iceberg, the thick steel plates did not rip open. The brittle, improperly crystallized iron rivets simply snapped under the kinetic shock, popping the seams open like a zipper over a length of 300 feet. The timeline of the official ledger is a mathematical impossibility. It required thousands of rivets to be perfectly heated and hammered flawlessly every single day, ignoring the metabolic failure of a human capital and the metallurgical parasitism of cheap iron.
But the skin of the ship is merely the outer shell. If the hull is a marvel of corporate negligence, the propulsion system is a nightmare of pure weight and thermodynamic physics. Deep in the belly of the Titanic sat 2 massive, 4-cylinder, triple-expansion, reciprocating steam engines. They were cast iron cathedrals. Each engine stood 4 stories tall. Each weighed 720 tons. Let that number sink in. 720 tons of solid, rigid metal which had to be lowered into the deep, narrow chasm of the ship's hull. Let us isolate the spine of these engines, the crankshafts. A single crankshaft weighed 118 tons. It was not a single casting. It was built up, assembled from separate forged steel pins and massive heavy webs. Let us audit the absolute precision of that thermodynamics. To combine these massive pieces, early 20th century engineers used a method called shrink fitting. You superheat the heavy steel web until the metal expands, insert the cold steel pin into the hole and let it cool. As the metal shrinks, it locks together with millions of pounds of compressive force. In modern heavy industry, shrink-fitting components of this mass requires computer-controlled thermal ovens to ensure perfectly uniform cooling. We are talking about assembling 118-ton dynamic components in a cold, drafty, uninsulated 1909 shipyard. A fraction of a millimeter of thermal warping on a massive crankshaft is a kinetic death sentence. When fully operational, these engines generated 30,000 horsepower. If a built-up crankshaft is misaligned during the crude open-air cooling process, the resulting kinetic vibration at 75 revolutions per minute would amplify exponentially. The eccentric rotational mass would literally tear the engine off its mounts. It would shatter the cast iron bed plates and rip straight through the bottom of the hull. How do you perfectly level, shrink-fit, and align a 4-story, 700-ton vibrating machine on a sloping slipway using plumb bobs, steam winches, and exhausted biological labor? Forensic engineering dictates that handling dynamic payloads of this density with absolute zero tolerance for misalignment was a blind, catastrophic roll of the dice with the laws of physics.
And yet, all of this staggering weight had to face one final terrifying test before it ever saw the open ocean. The ultimate paradox of gravity. May 31st, 1911. Launch Day. The Titanic is a completed hull. The engines are inside. The massive boilers are loaded. The ship now has a deadweight of 26,000 tons. 26,000 tons of steel resting entirely on dry land. This is the most dangerous moment in the lifespan of any vessel. A ship is designed to be supported evenly by the buoyant force of water along its entire length. It is not designed to sit on hard ground. If the weight is not distributed perfectly, the ship's own mass will snap its keel in half like a dry twig. To get the Leviathan into the water, Harland and Wolff relied on gravity. The ship was built on a slipway, a concrete foundation angled precisely at 7/8 of an inch per foot downward toward the River Lagan. For months, the 26,000 tons of the Titanic rested on thousands of wooden keel blocks. To launch it, the entire crushing weight of the ship had to be transferred from those static blocks onto 2 wooden sliding ways, a pair of giant wooden sled tracks. How do you reduce the friction of 26,000 tons of steel pressing down on wood so that it slides smoothly into the water?
The official record gives us the answer. 22 tons of tallow, train oil, and soft soap were smeared onto the wooden tracks. Let us apply thermodynamics to this primitive lubrication. You have 26,000 tons pressing down on a layer of animal fat. The pressure per square inch is catastrophic. When millions of pounds of dead weight begin to slide, the kinetic friction generates immense thermal energy. If the tallow layer is too thin in one section, the friction spikes. The kinetic energy instantly converts to British thermal units, driving the temperature at the point of contact past 500 degrees Fahrenheit. The fat boils away. The heavy timber tracks instantly catch fire. The ship stops moving on one side but continues on the other. It twists, the hull fractures, and the launch ends in a catastrophic mountain of scrap metal and dead workers. If the tallow is too thick, the ship accelerates too fast, overwhelming the hydraulic triggers holding it back, launching prematurely and crushing everything in its path. The margin for error is absolute zero. At 12:13 p.m., the hydraulic launch triggers were released. For one terrifying minute, 26,000 tons of steel slid down a ramp lubricated by animal fat, entirely at the mercy of gravity and crude friction coefficients. Mainstream history calls it a triumphant success, a testament to Edwardian engineering. But when you calculate the mass, the thermal friction gradients, and the sheer unpredictability of moving that much dead weight on wooden rails, forensic logic suggests it was not a controlled process. It was Russian roulette.
The Titanic was a masterclass in the illusion of control. From the mathematically compromised biological limits of the riveters, to the perfectly aligned four-story engines, to the gravity-defying launch on a bed of animal fat. We are told this was the peak of human industrial achievement. But when the numbers do not add up, we must track the corporate reality. The Harland and Wolff shipyard was not just a boat builder. It was a subsidiary tied deeply to J.P. Morgan and the elite financial monopolies of the early 20th century. These corporate cartels did not possess magical technologies. What they possessed was a ruthless, undocumented disregard for structural physics when it conflicted with their profit margins and timelines. They hoarded advanced hydraulic tech for the highly visible, flat sections of the ship, but deliberately deployed brittle, substandard iron in the critical curved impact zones to cut costs. They treated the staggering risks of assembling 100-ton built-up engines in the freezing mud and sliding 26,000 tons of steel on animal fat as acceptable variables on their balance sheets. They sold the public the illusion of an unsinkable, flawless marvel. But mathematically, the Titanic was a compromised structure from the moment the very first slag-filled rivet was hammered into the Belfast mud by an exhausted, starving worker. We bought the myth because it flatters our collective ego, because we prefer the tragedy of a natural iceberg to the cold mathematical reality of corporate negligence. But physics has no ego. Physics demands proof. The next time you look at the faded photographs of the Titanic, do not look at the grand staircase or the elegant dining rooms. Look at the steel. Look at the calculated risk assessment hidden in its creation. You are looking at a timeline manipulated by corporate monopolies. You are looking at a ledger where physics was compromised for scale. To our current auditors and new viewers joining the ledger, thank you for your continued focus. Hit the like button to bypass the algorithm suppression, and leave your localized architectural anomalies in the comments below for future deployment. If you want to support these ongoing structural audits, the Oversight Committee is officially open. Click the Join button below to receive your security clearance and become a field auditor. For our full forensic breakdown of corporate infrastructure laundering is on your screen right now. Trust the numbers, not the narrative. The ledger remains open.